Welcome to section 7.4, Trig Identities. Now this one is probably my most favorite of chapter 7 because it feels like we are undoing a puzzle. I really enjoy it, and I hope that you also get the satisfaction of figuring these things out the way that I do. So, our objectives are to use algebra to simplify trig expressions and also establish the identities that we know of in terms of using these simplification strategies. Okay, so let's get started. We want to rewrite cosine squared x plus cotangent squared x plus sine squared x in terms of cosecant. So what we want is an answer where we only have cosecant. So I'm starting with cosine squared plus cotangent squared plus sine squared. So what I'm going to do is I know that if I have sine squared plus cosine squared, I can rewrite it. So what I'm going to do is, since I can add things in any order, I'm going to write it as cotangent squared x plus sine squared x plus cosine squared, cosine squared x, because I know that sine squared plus cosine squared is 1. Cotangent x plus 1. Now, what do we know about cotangent squared x plus 1? Well, that is rewritten as cosecant squared x. And we're done. We've rewritten it in terms of cosecant. So satisfying. Okay, let's keep going. Simplify by rewriting sine x over cosine x plus 1 plus cosine x minus 1 over sine x over a common denominator. Okay, so we're going to treat this the way that we have always worked with fractions, where if we want a common denominator, we multiply both items by the denominators that we have, because that's the simplest way, well, maybe not the simplest, but definitely the quickest way to get a common denominator. So what I'm going to do is I'm going to take sine and multiply it by the top and bottom of that fraction, and cosine x plus 1 and multiply it by the top and bottom of that fraction. So we're going to have sine of x over cosine of x plus 1, and we're going to multiply it by sine of x over sine of x. Because we can also think of this as multiplying it by 1, so we're not changing the value, we're just getting a common denominator. And we're adding cosine x minus 1 over sine x, and we're going to multiply this one by the other denominator, cosine of x plus 1 over cosine of x plus 1. And this should result in a common denominator. So we have sine x times sine x over sine of x times cosine x plus 1 plus cosine x minus 1 times cosine x plus 1 over sine of x times cosine of x plus 1. Okay, so now we can notice that we do in fact have common denominators now, so we can add them. So that means we have on the top sine of x times sine of x plus cosine x minus 1 cosine x plus 1, and on the bottom we have sine of x times cosine of x plus 1. Okay, now let's simplify so that way we know what we're doing. So I'm going to simplify this one first. Sine of x times sine of x, I know, is sine squared x. And then if I multiply these out using cosine times cosine, cosine times 1, cosine times -1, and -1 times +1, right? Multiplying these binomials, we will have cosine squared of x plus cosine of x minus cosine of x minus 1 over sine of x times cosine of x plus sine of x. So we've multiplied everybody out. Okay, some things that we're noticing. We have a sine squared plus cosine squared. That gives us 1. A positive cosine and a negative cosine, so those two cancel each other out, and minus 1. And then we have the bottom, which really doesn't matter because on the top we have 1 minus 1, which is 0. So the denominator 0 divided by anything is going to give us 0. So that expression is equal to 0. And you don't get much simpler than that. We've simplified it all the way down to a number value. Okay, example 3. Verify the following identities. So we're going to look at 2 identities. This identity is 1 over secant x plus tangent x plus 1 over secant x minus tangent x equals 2 secant x. This is an identity that's been given to us. Verifying it just means make sure that it actually does. So go through the steps and prove that if I add these two fractions, it's going to give me 2 secant x. So the first thing I'm going to do is I'm going to start on this side, and I want to end with this side. So that's my goal. So I have 1 over secant x plus tangent x plus 1 over secant x minus tangent x. And what I'm going to do is I'm going to get a common denominator like I did in the last example. So if I have 1 over secant x plus tangent x, I multiply that times secant x minus tangent x over secant x minus tangent x, then plus 1 over secant x minus tangent x multiplied by the other denominator, secant x plus tangent x over secant x plus tangent x. Okay? Which will give us a common denominator, so we can add the numerators now. We have secant x minus tangent x plus secant x plus tangent x all over secant x plus tangent x times secant x minus tangent x. So I have tangent minus tangent on the top. which leaves us with 2 secant of x. And if I multiply these bottom, then I have secant times secant, which is secant squared, minus secant tangent plus secant tangent, which would be canceling each other out, minus tangent squared of x. And what I'm going to do is I'm going to rewrite the denominators in terms of sine and cosine, so that way we can see what the subtraction is that's happening down there. So on the top, I'm going to leave it alone for a few minutes, just so that way we get an idea of how we can simplify the bottom. Secant, I can rewrite as 1 over cosine. So secant squared is 1 over cosine squared, minus tangent is sine over cosine. So sine squared over cosine squared. And since they have a common denominator, we can subtract the numerators. So we will have, the top is just hanging out 2 secant x. On the bottom, we have 1 minus sine squared over common denominator of cosine squared. And if we recall, 1 minus sine squared, we can rewrite it as cosine squared. So now we have cosine over cosine, which is just 1. So our answer is 2 secant x. And that's what we wanted. So really I shouldn't have boxed this. I'm gonna put a check mark because that did in fact verify that this identity is factual. Okay. Now we're gonna look at this identity. Sine of x equals negative cosine x times tangent of negative x. This is going to reference the information they gave us about even odd functions. So we want to, I want to end here. So I'm going to start on this side and hopefully get to the end and have it equal sine of x. So I'm going to start with negative cosine x times tangent of negative x. And what we know about even odd functions is I can rewrite tangent of negative x. So I have negative cosine of x times negative tangent of x. And since I have a negative times a negative, I have a positive, so I have cosine times tangent. And now, since I have a cosine, I'm going to rewrite tangent in terms of sines and cosines. So cosine I'm going to leave alone, but tangent is sine over cosine. And if I multiplied these out, I would have cosine times sine over cosine. And these cosines would cancel each other out, which leaves me with sine, which is exactly what I wanted. So I have verified. And those are all the examples that I have for this section.